This session will illustrate how Teamcenter part planning and validation capabilities support the manufacturing planning process for part manufacturing. The session will illustrate capabilities from the following Siemens PLM technologies. Teamcenter will be used to create, track, and follow workflows and to release data throughout the organization. Teamcenter Part Planner will be used to define the manufacturing process plan, link machining data to process plan operations, and generate work instructions. Teamcenter Resource Manager will be used to access libraries of cutting tools and machine tools. NXCAM will be used for NC programming, post-processing of NC programs, and tool list generation. Finally, Shopfloor Connect for Teamcenter will be used to search for machining data in Teamcenter and access and deliver that data to the shop floor. This session will follow the case of a piece part, in this example, the Model B gearbox cover. This data is engineering data. As you can see, it's owned by engineering. It contains typical engineering data sets, like, for example, a UG master drawing from NX and a JT representation. I can view that JT preview of the part, which we're going to follow throughout this discussion. I'm going to start off by initiating a Teamcenter workflow on this part. The workflow stands for Part Planning and Validation Release using Part Planner and CAM. And this workflow will be used to guide our discussion and illustrate how Teamcenter can be used to guide the process of manufacturing data management. I've initiated the workflow on my engineering part, and we can see now that the part and some of its related data sets have now applied a status of design release. If I go into my work list, I'll see that I have a new task to perform in my work list. I can view an overview of the workflow process. The workflow starts with design release by engineering, and then from there guides the manufacturing process. In this demo workflow, we have two steps. A step where the part planner creates the process plan, followed by a step where the NC programming team generates CAM data on this process plan. This CAM data will include NC programs, tool list, and other manufacturing work instructions. Finally, the manufacturing data is released to the shop floor where it can be accessed by Shopfloor Connect for Teamcenter on the shop floor. In practice, we always build these manufacturing workflows according to the needs of our customers. We can include any manufacturing reviews or any other required business processes in this workflow. I'll switch to the task view, and as a process planner, I'm being prompted to create the process plan for the target part specific to the location or the plant where it's being produced. I also have some additional instructions about how critical parts should include inspection tasks at certain points throughout the process. I'll go ahead and drill into the targets folder of my workflow process and identify my target part. To produce this part, the process plan, I'll do a right-click, Send to Part Planner Application. The part is sent to the Part Planner application. The Part Planner application is where our process planner will create the process plan for this Model B gearbox cover. Now, as a part planner, I know that this part will be produced at our company's Chicago site. So I will open the plant structure for our Chicago site. I can search by name, and once I have the result, I can load the structure into the Part Planner application. As you can see, this structure has modeled our Chicago plant. This sample plant structure includes both logical grouping, for example, part manufacturing, and then within that, milling, turning, and EDM machining. But it also contains physical equipment. If I drill down, I'll see machines, actual equipment such as CTX mill, Okuma turning machine, and a Makino EDM machine. So our plant structure contains the logical and physical groupings of our Chicago plant. In the next steps of this discussion, we'll see some of the reasons and value of modeling the plant structure in Teamcenter. Now we'll want to create the process plan for our Model B gearbox cover as directed by our workflow task. There's many ways to create a bill of process in the Part Planner application. I could create one from scratch. Rather than creating a new process plan from scratch, though, I'll create it based on a previously existing process plan. Oftentimes, we see that customers have many bill of processes or routings which are very similar to each other and may come from a common process plan. This might be called a master routing. I'll leverage Teamcenter Manufacturing Resource Library to allow me to clone a new routing based off a master routing. I'll do a File, New, From Template, Process from Template. Here is where I'm being prompted to choose what should be the starting point or template of my new bill of process. I'll click Find Template by Class. This is our first look at Teamcenter Manufacturing Resource Library, which we'll see throughout our discussion today. As you can see, Resource Library is used to manage the resources of a manufacturing organization, including, for example, machining fixtures, machining tools, including both assemblies and components, and other potential resources such as robots, welding guns, etc., etc. In this case, I'll use the classification capabilities of manufacturing templates. In particular, I've classified several manufacturing processes which can be used as master routings. As you can see, I could search based off description or comment, but in this case I'll do a general search and view the results. I have here classified 3 bill of processes which are used as common starting points for other potential bill of process structures. In this case, I have a generic process plan or master routing for gearbox parts. I'll select this, and Teamcenter will use that template as our starting point for our new Model B gearbox template. I'll want to rename the new template to reflect that this is a specific bill of process for my Model B gearbox. I'll give it a name of Model B gearbox process plan, and under description, I'll indicate that it was cloned from master routing. I'll hit OK. And as you can see, Teamcenter has created a new bill of process structure. It created the same sequence of operations that were present in my generic model gearbox cover plan, except it gave new item IDs assigned. So I effectively cloned my original generic process plan to accommodate my new Model B gearbox process plan. What this structure represents is first an item representing the process plan. This item type is ME process. And then underneath this ME process, I have 4 operation item types. The first and last operations are of item type ME op. This indicates that they are general generic operations. In this case, I have a material procurement operation at the beginning and an inspection operation at the end. In the middle, I have 2 operations of type MENC machining. This MENC machining type is used to indicate machining operations such as drilling, turning, milling, finishing, lathe, EDM, so on and so forth. If I drill into each operation, we'll see that I have allocated equipment from my plant structure to the bill of process structure. Here we're essentially telling Teamcenter that each section of my plant structure is used in the manufacturing process at that operation. So for example, these 2 machining operations are both happening at my CTX machine, which is modeled in the plant structure. So in this way, we're assigning the plant structure element to each operation where it's used in my bill of process. Now that I've cloned a bill of process, I'll want to make it specific for my Model B. Now, I know from my workflow task that I was instructed to add a CMM inspection operation in between my two machining operations. To do that, I could either click this button, Operation, or I could do File, New Operation. Here is where I tell Teamcenter what sort of item, what sort of operation is being created. I'll use the generic MEOP item type. I'll let Teamcenter assign an item ID, and I'll indicate that this is a CMM inspection operation. Teamcenter created the new operation. However, we want the CMM inspection operation to be located in between the two machining operations. To do that, I'll demonstrate the Pert Chart by doing open with Pert View. The Pert View is where we define the sequence of manufacturing operations. In this case, I'll drag this off to the side, make a little room here, and place the CMM inspection task in between my two machining operations. Now I'll click the Draw Flow button and simply draw flow lines in the sequence of operations, which reflects the manufacturing process. I'll close, navigate to the Resequence Structure button and click it, and then Teamcenter will reshuffle this bill of process according to the order indicated in the Pert Chart. Now my CMM inspection is in between my two machining operations as intended. The last thing I want to do is associate my inspection area to my CMM inspection operation. To do that, I'll do a right-click, copy, right-click, paste. My inspection area was added as a work area to the CMM inspection operation. I've now instructed Teamcenter that this plant structure element is the work area for the CMM operation. Now, of course, as a process planner, I could now further detail and modify the process by, for example, adding operations, removing operations, adding resources to each of these operations, adding documents such as data sets to any of these operations, and adding any further detail to the manufacturing process. But as a process planner, I'm now satisfied with the process plan for this Model B gearbox cover. The next thing I'll do is link my process plan to the engineering part. To do that, I'll do a right-click, Link Associate, Associate Product as Target. I'll click on my Model B gearbox cover item and add it as the target for this manufacturing process. Now my engineering data is linked to my manufacturing data. One of the many reasons to link my engineering part to the manufacturing bill of process is to support change management. I can now perform, for example, impact analysis on my engineering part and easily see that this process plan might be relevant and linked to the engineering part. This could be useful as part of an engineering change workflow, for example. Now I'll go back to my work list, go back to my task, and indicate that the task is complete. The process has moved on, and we're now on the Generate CAM Data step of the workflow. If I go to my task view, I'm instructed to perform NC programming work on the target part. The output should include the NC program as well as supporting documentation. Now, I'll switch my role within the part manufacturing group from a part planning engineer to an NC programmer and hit OK. Going back to my task, I could again drill into the targets. I could, for example, view the JT preview of the part. I could view the bill of process for this part in Part Planner. And then when I'm ready to begin my NC programming work, I can directly open this target part in NX. Now NX will open up in modeling mode or drafting mode in this case, but as a CAM programmer, of course, I want to switch to manufacturing mode. Now I'm prompted to choose what sort of CAM session I want. CAM general is what we call the native mode, meaning all my post-process work and my CAM files are stored locally on the engineer's computer. For this demo, we're going to choose CAM Part Planner MRL. Part Planner indicates that the output of this session, including the NC program and the UG master, will be stored in Teamcenter. The MRL indicates that we'll use Teamcenter Manufacturing Resource Library for our NX tooling information and tooling library, as opposed to a native ASCII library. In practice, we would hard code this CAM Part Planner MRL configuration so the engineer never saw this, but I want to point out that we use a different CAM session configuration when the data is to be managed by Teamcenter. Upon selecting that, I'm prompted to choose which operation to work on. Now, since we linked the engineering part to the Model B gearbox process plan, I can now drill into that, and NXCAM is giving me the option to choose between either of those two MENC machining operations which were part of our process plan. The advantage here is that a process planner has already defined this process plan and both of the machining operations ahead of time. As an NC programmer, I simply need to select which operation I'll be working on, and all the content from my NXCAM session will be saved against that operation. So I'll select my milling, drilling, first clamping. From here, I simply select which NXCAM setup template to use like normal from my NX library. I'll go ahead and take a general assembly metric. And now we've opened things up inside of NX manufacturing mode. First, I'll rotate the part and make it a little more full screen so we can see what's going on a little better. At this point, I'll create a simple CAM operation and we'll save that data back to Teamcenter then. I'll create an operation. In this case, a simple floor wall operation will be fine for our purposes. I'll select our target part. I'll choose to machine this face on the underside of the part. For our tooling, when I click Create Tool from Library, what I'm looking at here is actually a structure of tools managed within Teamcenter MRL. Once again, I can search for a tool which is managed in Teamcenter MRL according to any of these different parameters, like for example, a cutting diameter. In this case, I'll just do a general search, so I'll get all the results back. And what we see here are a few tools which are being managed in Teamcenter. I'll go ahead and select this 10 millimeter diameter tool, Ed Mill. Okay, at this point I have everything I need to generate a very simple tool path for this face. And NXCAM has come up with the tool path. I'll hit OK. Now I can post-process the tool path and create some CNC code. So I'll hit post-process. I'll post this out for my mill 3-axis CTX machine and hit OK. NXCAM has generated my NC program, and of course I can view the result. At this point, I can also produce additional documentation, such as, for example, a HTML operation list. So NXCAM can easily generate shop documentation, which we can customize and configure according to business and manufacturing requirements. Okay, so we've produced just a very simple operation with a toolpath, an NC program, and an operation list as well. So I can come and do a file save. Now we get a dialog window telling me that certain data sets, in this case the NC program and the operation list, have not been saved. Of course, we want to save these to the database, so we'll hit OK and hit OK. So NX has saved our part session. So at this point, we could continue creating more CAM operations, creating additional NC programs, shop docs. But for now, we're finished with our CAM work. So we'll close out NXCAM. If I now go back to our bill of process in the part planner application, I'll drill into my milling, drilling, first clamping operation. I'll do an open with attachments. The attachments view is where we view data sets which are attached to an operation. And we'll note some following pieces of the integration which we're seeing. The first is that we have a UG master data set. This is the actual NXCAM data set which is created, which stores our operation, toolpath, and all the other CAM work. We also have this activity object, which contains a UGCAM program group. Okay, so this indicates our NXCAM program group, and within there we have a few data sets of interest. First, we have our NC program data set, which I can open and view. And we also have our operation list, which was stored again as a data set against the operation. So to recap, the process planner created and defined these machining operations. As an NC programmer, all I had to do was open up my engineering part, switch to manufacturing mode, select which operation I wanted to work on, and then all the output from that part was automatically stored in Teamcenter against the operation. We have the UG master, we have CAM data sets, and after refreshing the operation, which I just did, we also have our tooling assembly. You can see that 10 millimeter diameter end mill, which was used in my NXCAM session from Manufacturing Resource Library. That was also associated to my operation. So, now that we have created some CAM data against a Teamcenter bill of process, I'll go back to my work list, come to my workflow task, and complete the task. At this point, the workflow will terminate and this data is released to production. Now at this point, we've done our engineering work and manufacturing engineering work in Teamcenter. What we'll want to do now is take on the role of a shop floor employee, such as a CNC machinist, who might use Shop Floor Connect for Teamcenter to access the CAM data stored against the bill of process. So I'll go ahead and launch Internet Explorer. And Shop Floor Connect for Teamcenter is a web-based solution, meaning I simply have a bookmark here on my shop floor workstation PC, which I use to access the system. First, we log in with our Teamcenter credentials. So I'll log in with my Hyla user account. Now, the first thing that the operator does upon logging into the system is selecting which CNC machine he or she is working at. You'll recognize these equipment here as being the very same equipment which are modeled in our plant structure. You'll notice that the item type here is SFC Workplace, meaning these are the actual Shop Floor Connect CNC machine connections which are configured. I'll point out that this list is filtered in a few ways. First of all, we filter it based off the PC workstation on the shop floor. Say this particular workstation I'm working at is located in a work cell containing the CTX machine and the Makino EDM machine. In that case, I would only see those two machines in this list. I would not see the Okuma lathe. Secondly, suppose that as a user, our Hyla user is only certified to run the CTX machine. In that case, I would only have access to the CTX machine in this list. I would not see the other two machine tools. So we have the ability to filter this machine list based off of PC workstation and also by individual users. I'll select the CTX machine. Now this is the main operator interface. As you can see, it's an extremely simple user interface with very few buttons. I'll click the Get Data button to retrieve data from Teamcenter. Now, this is the out-of-the-box search screen, which contains item ID, item revision, and item name. What Hylasoft always does as part of any deployment is customize these fields according to the requirements and best practices of our customers. For example, at an oilfield services machine shop, we modified the screen to include only one field, which said part number. So operators would enter a part number, for example, 1, 2, 3, 4, 5, and hit search, and ShopFloor Connect returned all the CAM operations related to that part number. In this case, I'll just do a simple item ID search for our brand new operation, which we just created. 000283 and click search. So ShopFloor Connect returns the machining operations for this part for this CTX machine. First of all, these buttons on the left are dynamically populated, meaning only buttons which have data attached show up. So in this case, we have a so-called shop doc. If no shop doc was present on this operation, this button would not appear. So the buttons which appear on the left correspond to what data is available for this particular operation. Now I'm just going to go ahead and work top to bottom here. First, I can open my my setup sheet or other shop floor documentation. In this case, we have that operation list, which was generated by NXCAM. As an operator, I can use this to understand what operations are being done and even to access a visual of the toolpath and what the CNC machine is doing. Next, I might also have a JT representation of the part. I can open that up in a free JT viewer. So here my JT represents the finished part, but this JT could represent the part as it appears after the first machining operation, or after the second machining operation, or even as a raw material stock. I have a few pictures or drawings. In this case, I have the two-dimensional drawing of the engineering print. This could include dimensional data, part measurement information. I'd like to point out as well that those last two data sets, the drawing and as well as the JT, were both attached to my engineering data. Recall that both data sets are actually stored as data sets against my engineering part. Here's the JT representation and here's the drawing. However, since I linked my engineering data to my manufacturing data, you can see that ShopFloor Connect also fetched the data sets related to my engineering part as well. So by linking engineering to manufacturing, we can also return data sets and files related to the engineering part which might be valuable on the shop floor, such as a 2D print or a 3D JD representation. Furthermore, in this case, I have a simple picture of the tooling assembly. Since I used Teamcenter Manufacturing Resource Library to accommodate my NX tooling, some of that tooling information was linked to my bill of process operation as well. Finally, we have the G code itself.